this signals the start of a new unit. Okay, what new word do you see on the board that you haven't seen so far this semester? Equations. And what does equations make you think of? Well, it makes you think of equal, sure, and then if we were to build on that, it make you think of an equal sign. So that's a new symbol that we're going to be introducing today. Okay? So part of understanding about equations, even though it's really, really boring, you're going to have to stay with me through this one because it's going to really, really bore you out here, is understanding the difference between equations and expressions. If you remember last term, you took a performance final right before the actual final. Well, that one, I had to work in coordination with other teachers. I didn't get to write it, but since this semester I'm the only teacher teaching this class, I'm the one responsible for coming up with that. And that's kind of like, if there's like an essay nature to it. Doesn't work well when you're wearing a hoodie, but you can just take it off completely, use your hands and all your appendages too. There you go. Long story short, that's one of my favorite essay questions to write, so it'd be a good idea to understand the differences here. What's the main difference between an expression and an equation? Well, an equation is two expressions, not just two expressions, two equal expressions. What shows that they are equal? An equal sign. An equal sign is a comparative symbol. It says that two things are the same, yeah, not just alike, but two things are the same, yeah. Oh. So, too many times you guys just think, oh yeah, every problem is an equation, and I'm gonna solve the problem and solve the problem. No, not every problem is an equation. Well, what we've dealt with so far are expressions. And what do we do to expressions? If we think of like verbs and things to do, what did we do to expressions? Very good, we simplified them. Expressions just get simplified. In algebra, what are the two most common types of simplifying? Distributive property and combining like terms, which is what we did. What do we do to equations? That would be another difference. Okay. Then, all right. Well, what does it mean to solve? Because this should be the first time we're using that word. Well, solve. Let me say this over and over again. A synonym for solving is isolating. When you are solving, you are isolating. What are you isolating? The variable. When you're watching a like a crime drama, that's like a movie, and then the detective is investigating, and we want to see who committed the crime. Okay, well, what that detective is trying to do by solving, the murder mystery, is taking something that is unknown. At the time, we don't know who did it, and then make it known. In math, what do we call an unknown number? A variable. So we take this unknown number, and another difference between an expression and an equation is by the time you're done with an equation, you shouldn't, by solving, you should know what that variable is. By the time we're done, you should be able to tell me x equals 5, y equals -2. And we take an unknown number and make it known. How bored are you now? So how do we isolate? How do we solve? Well, we do the opposite operation. You have to identify, in order to get a variable by itself and isolate it, I have to cancel out all the numbers that are around it. I do this by doing the opposite operation. How do you cancel out adding? You subtract. How do you cancel out multiplying? You divide. How do you cancel out an exponent? We haven't done it this year, but you might remember. What's the opposite of an exponent? What's the opposite of an exponent? How would you cancel out an exponent? And not that we need to know it now. Huh? No. It starts with R and ends with radical. A radical, yeah. You guys know the most common radical you've worked with is the square root, but there's other types of radicals too. And then this is more just kind of a side note. You can put like a little star by this if you want, because some children forget. That make sure that by the time the variable has been isolated, make sure that you do not end up with a negative in front. Whoa, what does that mean? That I'll never get a negative answer? Like I can't have a negative no, you can get negative solutions. Just make sure that like when that variable is isolated, that you don't have a negative in front of it. Because then the variable is not isolated. You got to get rid of that negative also. Somebody last period actually impressed me and told me, oh yeah, mister, you get rid of that negative by multiplying by -1. And that's absolutely correct. If you need to get rid of a negative in front of a variable, you multiply by -1. See, it's catching on. That's good. Everybody's good. This last part is more for the next lesson, but I already had it on this lesson. I was like, yeah, you know what, I'll leave it on. And it has to do with more, well, how about if there's more than one number to get rid of? If we have to cancel more than one number, how would we do the opposite operation? How would we get rid of all the numbers around? Well, most books will tell you to do reverse order of operations. Back in middle school, you probably learned order of operations. What is order of operations? ¿Qué es lo que es order of operations? Seriously? You guys don't know what order of operations is? Yeah. PEMDAS. Please excuse my dear Aunt Sally. But PEMDAS is an order for simplifying. What types of problems get simplified? We just said it 5 minutes ago, maybe 7 minutes ago. What types of problems get simplified? Expressions get simplified. When you're going to do operations, yeah, you do parentheses first, and then you do exponent, then we do multiply and divide at the same time. I'm actually a bit stuttered away. It's supposed to be on the board. And addition and subtraction also at the same time from left to right. But when it comes time to cancel operations, because that's what solving is doing, we're using our ninja skills to chop away those extra numbers that we want to get rid of. Yeah, they tell you to go backwards, reverse, SATMAP. Kind of like the way that Emma's going to feel tomorrow if there's no school, SATMAP. You would look to cancel out adding and subtracting first, then cancel out multiplication, division, then exponents, and then finally parentheses at the end. You work your way backwards if you're trying to solve. But you won't need to worry about that today, because today all of our equations will have just one step. That's why when you have multiple steps. Well, this reverse order of operations things can be confusing sometimes. So kind of a less formal way of learning this is when you learn to simplify back in the day, back before the mean variables were brought in, you learn to go inside out. Start in the innermost parentheses and work your way out. When you're canceling operations, work your way outside in. Start the farthest away from the variable, and then so cancel outside, work your way. Oh man, that's a board face. Hang in there, buddy. Times they are changing. Example time. Huh? Hey? Huh? Okay. So this is an equation. You see an equal sign, it's a comparative symbol. There's two expressions. The expressions aren't very long. On one side, we have an expression that says x minus 28. That cannot be simplified because they're not like terms. On the right side, we have just a 49, which also cannot be simplified because that's just a single term. But what does it mean to solve? When I am solving, what am I doing? I'm adding? No. When I'm solving, what am I doing? That No, you're definitely not simplifying. That's correct. When I'm solving, there was even a big word that was capitalized, and I drew an arrow to it, and I said I'm going to say it over. Thank you. I am isolating. You've probably heard others say, hey, think of this equal sign as being a wall. And the X is kind of a loner. It marches to the beat of its own drummer, and it doesn't want anybody around it. So who's being clingy with the X right now? The negative 28. So I would want nothing more than to get rid of it. But what's that 28 doing? What operation? Yeah, you have to identify the operation first. Soha's already done it, so she's just waiting for other people to do it. What operation is that 28 doing to the X? If you just said negative 28, if I were to read that, that says X minus 28. Yeah, and we're doing the opposite operation. What's the opposite of subtraction? Addition. So I would love to cancel this out by doing plus 28. If I could somehow add 28, then it would go bye-bye. But what that equal sign says is, hey, well, yeah, you can do whatever you want to one side as long as you do it to the other side too. But I think it's a problem. I think other teachers kind of teach it more this way. I mean, whatever. Where people say, oh, yeah, you just move it. Well, yeah, that negative 28 just moves to the right side and it becomes positive. And yes, practically speaking, I guess you could say it does. But that's not the reason why. The reason why is because you're doing it to both sides. You can do whatever you want to an equation. You can't do it not to an expression, but an equation, since you have that balance, you can do whatever you want on one side as long as you do it to the other side. On the left side, all that happens is those 28s cancel and I have the X by itself. Yes. Radical 77? Facts. It is 77. Why didn't you just say that in the first place? It's like a minute of my life that I'll never get back. And in any equation, whether it's one step, two step, linear, quadratic, any equation, if you ever want to check and you have the time to burn, you can always get your solution and plug it back into the original equation and see if it makes that sentence true. Take a wild guess what 77 minus 28 is. It's 49. No caps. I couldn't hear what you're saying because I'm wearing my earbuds. I'm trying to look cool. Featuring ASAP. You know what that is? Cool. How about here if I want to get the Y by itself? Yeah, and people look at you, oh, but Mr. Look, you're adding. So since I'm adding, I have to subtract. And yes, you are correct that it's adding, but it's not adding because of that plus sign. That plus sign belongs to the Y. The reason why you're adding is because the 21 is positive. And if I want to get rid of it and I do the same thing to both sides, I don't just move the 21 magically with my mathematician powers. I subtract 21 from both sides. You're only going to have to really subtract on the right side because all that happens on the left is that they cancel out. Yes, negative 18 minus 21 is negative 39. Any questions? Ooh. Ruben. What do you want to do here? What should I do here, Ruben? With the 25? Well, see, the problem with the 25, so problem with the 25 is the 25 is already on the other side. I want to get the x by itself. And in this case, the x is on the right. So who's the number that's bothering? ¿Quién está molestando el x? Well, the 150 is. But then the other problem people run into is like, hey, look, but we're adding. So then we can subtract. We know that plus belongs to the x. I need the x to have that plus in front. What does the 150 have, or the 150 as they say? Yeah, so I have to add 150. And hope, even if you are kind of unsure, like, oh man, fingers crossed, I hope I got this right. Yes. If you're ever not sure if you got it right, you can always plug it back in and check. What is negative 150 plus 170 fizzle? It's 25. No? Yeah, man. Do whatever you want. It's your world. That's why they call him Lil Exivert. What? Sorcery. Yeah, before you get too excited and start doing things, there's back to back, there's a double negative. So what is the double negative the same as? So I would advise you, not that you have to, but you want to avoid a mistake, rewrite this as x plus 25 is equal to 15. So now Jonathan can tell you how to get rid of the 65. You're going to add more 60, you're already adding, but then add more. I want to get rid of a plus 65. I would hope that you could subtract 65 from both sides. No, all the kids are doing it, so it keeps your ears warm. Right, for Celine? Everywhere. But that's kind of the cool part about it, is you just kind of let it go, and it just kind of makes it look like you don't care, you know? Just like, yeah, whatever. Huh? Yeah. I'm like the Versace of my generation. Okay, let's continue isolating. That's what all the cool kids are doing, are isolating. Yeah, right. Now you just ruined it with fractions. Well, fractions are numbers too. They have feelings. They want to be treated like the rest of the numbers, just not with hoodies on. How do I get the G by itself? Well, no taking. Taking is not a math word. How? No, the canceling is not a math word either. I want operations. Give me an operation to do. Good. Subtract 3 over 4 from both sides. Yeah, well, the left side you don't care about because that's just going to cancel. But how I don't like. Well, I would advise you to rewrite it horizontally. That's just the way I do it. There was one point where I felt more empowered into like forcing kids to do it this way, but frankly nowadays, well, you want your world. But what you would need to know is that in order to add or subtract fractions, they have to have a common denominator. So right now, fractions do not have a common denominator, so we have to make them common. So I'm going to rewrite and say g equals negative some fraction minus some fraction. Common denominators are the same thing as common multiples. Okay, what multiples are, like, think about, like, if I'm going to count by a number, like 2, 4, 6, 8, 10, 12, or like 5, 10, 15. But now, if I count by 8s and 4s, so like 8, 16, 24, 32, 40, 48, 50, no, 48, yeah, 56, 64, 72, 80, 98, 96, 104, 4, 8, 12, 16. You definitely couldn't do 4. You could do 16, but there's a better number than 16. No, 2. 2 is a common factor. It's not even, we don't want factors, we want multiples. I need multiples for this. I'm not looking to divide those numbers. I'm looking at, if anything, to multiply those numbers. What's the smallest number that both 4 and 8 fit into? Ocho. Because 8 doesn't go into 2. 4 doesn't go into 2. They have to be multiples of that number. That's why I was giving that list of numbers. It wasn't just to look cool. My earbuds are already doing that for me. It was just because that's what we're working on. So here, this first fraction becomes this fraction. This second fraction becomes this one. So on the first fraction, the bottom 8 stays as an 8, so the top 1 gets to stay a 1. On the second fraction, though, the bottom changed. The 4 became an 8. And since we're using multiples, 4 times what gives you 8? 2. So don't just put a 2 like Dario would do. Put 3 times 2, which is 6. And this is where the miracle of technology works, right? This 4 turns into an 8. How? By doing times 2. So the rule is whatever you do on the bottom, you have to do on the top. What is 3 times? Well, because here, the 8 stayed as an 8. That was 8. This was 8 times 1. So what's 1 times 1? This fraction went through the portal and turned into that fraction. Independent, it's its own. The second fraction became this fraction down here. So your question is, well, why didn't I multiply the 8 times 2? Well, because we decided that the least common multiple was 8, right? Again, I'm trying to explain that to you. If I look at the first denominator, I started with an 8 on the bottom, and it became an 8. 8 times what gives you 8? 1. Oh, so what is 1 times 1? That's why they pay me the big bucks. Here's a 1. So what is negative 1 minus 6? If you're not sure, ask Roselyn. Good. Add the numbers, keep them negative. This man be tripping. And then, oh my God. What do you want to do here, Ike? Isaac, I want to solve for W. You want to solve for W. We want to solve for W. No? Emilsi knows. When in doubt, ask Emilsi. No me gusta. Mo. Hey, Mo, what do you know? How do I get W by itself? Distribute. He is bugging. Yeah, I don't want to. That's a tough one. Lana, you want to help him out? Add 4 over 5. I want W to be by itself. Even though there's a plus in front of it, that plus belongs to the W. To get rid of the negative 4 over 5, you add 4 over 5. Now let's continue the education of Jason Babb. We have 2 fractions. I'll rewrite them horizontally. In order to add fractions, you need to have a common denominator. What is the least common denominator of 3 and 5? 15. So the first 3 became a 5. How? Multiplied by 5. So 2 times 5 is 10. The second 5 became a 15. How'd you do that? By 3. So 4 times 3 is 12. So now when you add fractions, you only add the numerator. The denominator stays the same. The only thing that you may have been taught to do in the past is to convert back to a mixed number, but we don't like it. There's 2 things that we don't like in this class: cold ears and mixed numbers. Oh, okay, 3 things. You're right. Phones also, yes. No, earbuds we like. We're rocking them. Should have brought my hood today. Any questions?
No.
Ooh. Multiplication missions. Facts. What? Well, see, here's the difference. David said to do the same thing you always do. Yes, I would do the same thing I always do, and I would get it right. But if you guys do the same thing that you always do, some of you would do this and go, yeah, -3 minus 3. Because you have to identify what is that 3 doing to the x. The 3 is being multiplied. And then Rosalind knows what's the opposite of multiplication? Division. Now here's another tricky little part, right? Even if you know that, some of the children say, yeah, I divide, but look, it's supposed to be the opposite. So divide by -3. No, not when you're dividing or multiplying. You divide by the same number. So 3 divided by 3 cancels. X equals, as the cool kids say, foe. No, they say foe. ASAP would never say ours. If you were real. No. It's all about the street cred. Correct. Until the first album drops. And then after that, you become a business man. What do you think, John O? Here, you want to add 6? Shush. John O, what do you want to do? Add 6? What? Add 6. Emma? What do you want to do here? Divide by 6. Thank you. This says -6 times then. So if you want to get rid of it, you divide by -6. What's that? It's all Emma's fault. So -7 equals n. No, but my other teacher taught me that the variable has to always go on the left. No, that's not true. You did. It doesn't. That's what the equal sign means. It means the same. Like if your first name is Roseling or Joseling, it doesn't matter because you both want to put your head down in class. It's the same. Lo mismo. He's just tired of girls picking on him, and he's not gonna have it anymore. He's taking a stand. Okay, what's happening to the x here? It is being divided by, oh, that's true. The x is taking Emma's book back. You're right. But it's also being divided by 7. So what's the opposite of divided by 7? And we show multiplying in algebra with parentheses. You're a dot. Does that really? Elsie hasn't taught me that yet. She knows all the bad words, but she hasn't taught me that word.
Oh my god, you just got yourself a hole, bro.
A hole, bro?
Holy crap.
I don't know. I just thought we were talking about bad words. He said I said a bad word.
Let's get back to math, guys.
Any questions? Well, you know what would cheer you up, Emma? If you told me what to do here. Good. That's your calculator? Negative 12's cancel. Yeah, your calculator broke. You can do negatives on my calculator.
No, because if I went like negative 12.
David, why are you sitting and standing? Are you? That might take a while. Why don't you just complicate? How do you solve here? I multiplied 3 times negative 12 is negative 36. No more fractions. What? No. Yep. Nico, how would I get the x by itself?
I presume. A balloon. Now, I'm not going for a stretch here, you know. I'm not as smart as that what we're doing right now.
You are a smart guy. Go do it.
Okay, you multiply. Okay, good so far. You multiply. And then you cut me in there. 30, right?
Good.
30, I got it.
The opposite of dividing by 30 is multiplying by 30.
Put it in the other stuff. This stuff.
But that's when all the heck breaks loose. Mm-hmm. So not necessarily that you have to do this, but so that you understand, since the 7 over 10 is already a fraction, how would I write 30 as a fraction? Heck no. So you have 2 options. You can either, see, with adding and subtracting, you only add and subtract the number on the top. But multiplying, you multiply both, like you multiply straight across. 7 times 30 and 10 times 1. But that sometimes might make your numbers too big, and then you won't like that. So the other option is you can actually take advantage of the fraction and the division. Yeah, and you can look to reduce first. Is there any number on top that has a common factor with any number on the bottom?
Yes,
30 and 10 can both be divided by 10, so you can do so. This becomes a 1, this becomes a 3. then since Hope has a calculator, which we just found out has negatives, even though there's no negatives here, what's 7 times 3? I reduced first. 30 and 10 can both be divided by 10. If any number on the top has a common factor with any number on the bottom, you can divide. Yeah. 30 and 10 can both be divided by 10. So what's 10 divided by 10? 1. What's 30 divided by 10? 3. So if you can understand that part of it, well, now what's 7 times 3? 21. Then you go, wait, what happened to the fraction? Okay, well, what's up on the bottom? What's 1 times 1? What's 21 over 1? Just 20. Yeah. The butterfly? I don't know what you mean by butterfly. Thirty times 7 and then 10 times 1? I'm not sure. I don't know what you mean. Luckily, we have a few more fractions coming. Diana, what do you propose here? I want to get the x by itself. How would I get the x by itself? He's just telling you that you're number 1. That was just his way of telling you you're number 1. Later, after school. You guys can meet by the monkey bars. It ends today. Maylee, what do you want to do here? Xavier. Okay, well, she correctly identified that the 2/3 is multiplying with the x's. She said divide, and with that respect, she's correct. But unfortunately, the type of number that's there, a fraction, fractions can't be divided. So hopefully in the past you've seen this before. What's the alternative for division? And this actually always works for division. You only really just need it with fractions. What is the same thing as dividing? Yeah, dividing is the same as if you multiply by. It starts with R and ends with reciprocal. If you want to divide 2/3, which is what Mandy suggested, and it's what we're doing, we just can't do it that way. We flip the script. Multiply by 3/2. That cancels everything out on this side. Times 3/2. Now this just became like the last one. You don't have to write it, but if you want to, 18/1, 3/2. You can do 18 times 3 and then 2 times 1 and then divide. But I like to live dangerously and divide first. Do you see any number on the top that can be divided or reduced by any number on the bottom? Yes, 18 and 2. 18 and 2 can both be divided by 2. This becomes a 9. This becomes a 1. So then all the children rejoice when they find out that x is equal to 2. Fax machine. So has been quiet today. The other Soha, the one. So here you go, Soha. Now you can totally redeem yourself. What do you want to do first here, Soha? You want to leave? You can't. Yeah, as much as you hate fractions, we hate these even more. Huh? Every mixed number can be rewritten as an improper fraction. This one's negative, it's still going to be negative. The denominators always stay the same. We just got to figure out what's in the numerator. And you probably learned this before. start with the bottom number, work yourself around, and multiply and then add. 3 times 8 is 24, plus 3 is 27. 5 times 1 is 5, plus 4 is 9. For the second problem in a row, Soha, how do you cancel out multiplying times a fraction? No, we don't divide. That's what Maylee tried, but then I corrected her. How about if you're wearing a hoodie, though? Can you still do it? No, you can't, so you should take the hoodie off. Is that like a hood inside of a hood? Yeah, that's what it looks like. It's not. It looks like it's not part of the actual. It's like what's that movie? What was that movie called? When there was like a dream and it's like the inception of hoodies. There's like a dream inside of a dream inside of a dream. So times the reciprocal. Don't flip the 9 over 5. Flip the negative 27 over 8. That's what I'm trying to cancel. I'm trying to cancel the negative 27 over 8, so I flip it. Because that's on the same side as the variable. That's the one I want to cancel. What is positive times negative? Negative times positive is positive times negative. Negative. Whoa, but look, those numbers are too big. That gives me like 72 over 135. I'm not even going to know how to simplify that. That's why we simplify now. 9 and 27 can both be divided by 9. This becomes a 1. This becomes a 3. So I get negative 8 over 15. And then I drop the marker. Got one more left. One more. Okay, last one here. What should I do first? No, first thing you do is convert. We don't want to deal with that mixed number. Keep the 5 on the bottom. 5 times 4 is 20. Plus 1 is 21. Convert a mixed number to an improper fraction. Yeah. How's what? How is that a 15? 8 over 50. Because I reduced 9 and 27 can both be divided by 9. 9 divided by 9 is 1. 27 divided by 9 is 3. So 1 times 8 is 8. 5 times 3 is 15. So here, yes, you want to divide by 3 as Emma started to say, but that works well on the left side. It doesn't work well on the right side. So that little gimmick that we just learned, we can always use it. What is dividing the same as? Multiplying by the reciprocal. What's the reciprocal of 3? So instead of 3 over 1, it would be 1 over 3. Multiply. Cancels. Y equals 3 divided by 3 is 1. 21 divided by 3 is 7. Not that you have to do it in that order. But now 7 times 1 is 7. 5 times 1 is 5. Good job.